Let's take a look at how to create loops in Python. First of all, in Python, whitespace matters. So tabbing is an important part of the language in terms of Python being able to understand what we mean. Some languages use braces and other symbols to put blocks of code together. Python does it with whitespace. The standard indentation is 4 spaces. If you're using idle, you just tab, or if in certain situations it will automatically tab for you. If you're using a different system, then sometimes you have to adjust the tabbing to make things work correctly. You can use, say, a regular text editor to do things. You just have to be careful, again, with the spacing, to make sure that Python can understand exactly what we mean. If things are not tabbed appropriately, then there are error messages that come with, and if you see this happen, if you make these mistakes, the error message is clear enough that you can tell what is happening, at least in most cases. The other thing that happens with whitespace is, from our perspective as a user or reading someone else's code, it just enforces the readability. It makes it easier to read and tell what's happening. And so that's a useful kind of side effect of the way Python uses whitespace. So we're going to talk about loops. And in any language, if you have a block of code that you want to repeat, you can just repeat that by copying and pasting if you chose. A big concern with that is that the copying and pasting, if you made a mistake, say a syntax error or a logic error in the first time you wrote the code, if you copy and paste that throughout lots of different places in a program, you realize that there's a mistake, you have to go back and find every single place and make sure that you have everything fixed and so on. So just on one hand, we don't want to repeat ourselves in code. There's a kind of a way to remember this in terms of having wet code or dry code. Wet code represents this situation of having repeated yourself. So write everything twice. You don't want to do that. You want dry code, which means don't repeat yourself. And so this idea is that you would like to write things one time and then be able to use that appropriately in different places. And that way, if you have made a syntax error or a logic error, you fix it in the one place and it's fixed throughout. We're going to come back to this multiple times and see this idea of creating blocks of code that can be reused without being copied and pasted somewhere else. So what we're going to do in this situation is look at the scenario where we want this certain block of code to be repeated either a certain number of times or until some particular condition is satisfied. And so this is the idea of a loop. And so in Python, we have multiple ways to deal with loops. We're going to look at counted loops, and then we will look at indefinite loops that may be completed an arbitrary number of times or maybe even not at all. But counted loops will be completed a specific number of times that we specify at the beginning. So in Python, we can count, we can go through a counted loop by value. And so entries in a sequence can be looped through. We think about the sequences that we've seen. We've seen strings, tuples, lists, and mentioned that there are other kinds of sequences as well that can be considered. But what happens is, say we have this particular sequence that we've just have a string, and the string is some characters in this case. So for a counted loop by value, we can say for character in sequence. And so this for character is now a new variable that we have created on the spot. and it's going to take on the value of each of the characters that are in the string. So when it begins, it will begin with the capital S, and then become the O, the M, the E, then the space, that's one of the characters, and continue on and looping through each particular character in the string. So if we print the characters, or print character, right, that's the name of the variable, what we will get is, because print will print the thing and then go to a new line, it will print some characters down the page with the space included as well, because again, that is one of the characters in the string. If we change sequence to be the string sum, and we have the same scenario, it's a 4-character in sequence, but this time we print hello, what happens is Python will look at the character, it begins with the capital S, and it will print hello, but the capital S is just there for counting purposes. The capital S isn't part of what is printed. So what we see in this case is we get hello, that the first hello is for the capital S, the second one is for the O, the M, and the E. So we have counted and completed this looping based on how many characters are available to us. Let's suppose we have a sequence that is now changed to 1, 2, 3, 4. So this is a list, values 1, 2, 3, 4. For num in sequence, we can print num, and we know what's going to happen. It's going to look at the first value. Its value is 1. It'll print that. New line, print 2. New line, print 3. Then print 4. And so let's say we had a string that is word. So word equals sum again. And now we're looking at combining these two issues. We have for num in sequence. That's still the sequence 1, 2, 3, 4. Now we're going to print num, and then we're going to print word that's at position num minus 1. Now if you think about the position num minus 1, this is because of the index. The values are 1, 2, 3, 4, but the corresponding index value is 0, 1, 2, 3. So what we're going to do is we're going to look at the word sum, and we're going to print a 1, and then the S, so that says the first letter is S. This is separating from the index to the counting procedure of the first letter, second letter, third letter, and then fourth letter. So it prints the value from the sequence, and then it prints from the list sequence, and then it prints the letter from the string sum. So we can count in different ways. We can mix and match, and there are times when we want to use a sequence for counting purposes, and then you apply that to some other scenario. Another way to create a sequence that we can use in lots of different ways is a built-in function in Python called range. Range creates a sequence. We typically, in the parentheses, put in a single positive integer that we tend to call I in general cases. But we put a particular number in place, and then the function range creates the sequence 0 up to I minus 1. So if we said range 2, it would give us the values 0 and 1. So 2 values beginning with the 0. And so when we're looping through the index values of some sequence, then the range gives us those index values. Say, hey, range of 10 is going to give us 10 values, but those 10 values will start at 0 and end at 9, and those will match the index of a sequence. So when we're going through, let's say we have for I in range 5, and we print I, what will happen is we will get the values 0, 1, 2, 3, and 4. So 5 values starting at 0. If we don't want the entire sequence, we can change the parameter a bit. In this case, we say for I in range 3, 5, print I. And what happens in this case is we start at the value 3 and go to the end of what range 5 would have given us. So we get the two values 3 and 4. So we start at 3 and go up to, but not including 5. Again, with range, we have to get used to the idea that it's indexed on a zero-based index system. And so it will start at 0, and we have to just keep track of where will this value stop. Now, something else that we might want to do is we might want to go in reverse order. And so there's this scenario as well. We can say, let's go, the range started at 5, go down to 1, but go by -1. So the first value is the start, the second value is down to, but not including. And then the -1 in this case says, let's count down by 1. So when we print this, we would get 5, 4, 3, 2, from 5, starting at 5, going down to, but not including 1, counting down by -1. You can also count up, you can count down, you can count up by more than 1, count down by more than 1, just by replacing that third value in the parentheses, in those brackets after range. So whatever choices you want, you need to experiment a little bit to see exactly how things will work, to see what values you get. Make sure you're getting the values that you expect. Sometimes we just want to start at the beginning of something and go to the end, and we know how many there are. And so range is really useful in that case for calculating or counting things by index. Again, there are times when we want to make other variations and go in different ways, and range is robust in that way and allows us to do multiple different tasks. So we had a sequence that was 5, 10, 15, and 20. Again, a list with these particular values. We could use range in this way. Instead of knowing how many values there are ahead of time, we could say, okay, for I in range length of sequence, and since the length of the sequence is 4, this line corresponds to for I in range 4. Again, I in range 4 is going to give us the values 0, 1, 2, and 3. If we then print sequence bracket I, that will print sequence 0, sequence 1, sequence 2, and then sequence 3. And so that will give us the values 5, new line 10, then on a new line 15, and on a new line 20. And so range is really useful when we need to do things by index and we don't necessarily know what the index values are to begin with. We can allow Python to do some of this work for us. We can determine how many things there are. That uses the length function, and then use range to fill in the index values and do this counting by index. So sometimes we want to count things by value, and sometimes we want to count things by index. And often the situation, the scenario will tell us which is better. And sometimes there is no better. It just, if you think about it one way, then it's by value, and if you think about it a different way, it's by index. And so it's a nice tool to have to be able to do counted loops in more than one way. Again, often there's a kind of a right way for a particular context, but if you use a different method, then that still can be appropriate, and Python can still give us the desired result. There are some things that if you are going by value in Python and you need to find out the index, there are ways to do that, but that's a bit beyond what we need to do now. So we'll think about counting by value, counted loops by index. Other times, though, there are other kinds of loops that the counting doesn't work for us. Sometimes we don't know how many times a loop should be completed, or even whether it should be completed at all. Sometimes certain loops will only be completed if a very specific scenario has taken place. And so if we don't know how many times a loop should be completed, or even whether it should be completed at all, then we can't use the counted loop procedure that we were just discussing. And so if it should only occur in certain situations, then we need to be able to test whether that situation has been met. Sometimes we want a loop to continue until a certain condition is satisfied. So we either check ahead of time to see, do we even carry out the loop, or we carry out the loop and then check at the end to see, have we met our condition yet? And if not, repeat the loop. And so there are two approaches in terms of loops in this way as well. So we're going to need to think about a different way to create loops. And so in these cases, we need a different set of tools. We need to be able to look at a condition and see whether that condition has been satisfied. And so to consider this, we have what are called Boolean statements. Boolean statements are these fundamental objects in binary logic that are either true or false. And so the idea of it being true or false is, if you think about a statement like "it is raining," you have to interpret that in some kind of context. "It is raining" could mean it is raining here right now. It could mean it is raining somewhere right now. There are issues with what exactly, how much water falling from the sky requires or allows us to consider that it is raining. So the contextual issues of a statement like "it is raining" can actually not be so clear of whether the statement is true or false. Luckily for us, we will mostly be dealing with mathematical expressions, much less ambiguous, and so we can look at statements and determine whether they are true or false. Is this number bigger than 7? Or is this value equal to that other value? And so either it is or it isn't. And so we can focus on just the true false issues and not be focusing on some external kind of contextual issues and so on. So these kinds of logic statements that are true or false are often called Boolean statements. They're named after George Boole, who described this kind of algebra related to logic in the 1850s. And Boole was kind of instrumental in not a revision of logic, but updating the ways to think about logic from kind of the times of Aristotle to the 1850s, creating a more modern approach to looking at logic and true statements and false statements and so on. Boole was an English mathematician, a philosopher, a logician, who taught at Queen's College, Cork, which is now University College, Cork, of the National University of Ireland. What he did allowed for several other further advances in logic and understanding what you can do with logic, and also understanding the limitations of logic and limitations of mathematical thought in general. There's a lot of interesting things that can follow from Boole's work and from people who followed. So Python has a Boole data type to represent this type of expression. A Boole data type is one that we haven't mentioned yet. It has a value that's true or false. So Boolean statements sometimes are thought of as being true or false. Sometimes are thought of as having values 1 or 0, with 1 corresponding to true, 0 corresponding to false. Sometimes the values are thought of as being on or off. The power button on a device looks like a 1 inside of a 0, so you can think of that as being on or off. So depending on different context, then it might be better to think of something in terms of numerical type values or to think of something in terms of true or false. So it depends on the context. Boolean expressions can be combined to create other new Boolean expressions. So to do this, we take either a single Boolean expression and do something to it, or we take two Boolean expressions and combine them. And the fundamental operations are and, or, and not. And or are binary operations. You take two Boolean expressions and put them together to get a third one. Not is a unary operation, which means you apply that to a single Boolean. And so what happens is you apply this to these statements, and then the truth values will correspond according to specific rules. So and operates kind of like a no carry multiplication. We don't have to worry about the no carry portion right now because we're just dealing with single bits, true or false. And so it's not exactly, well, it's not exactly a multiplication, but it is based on the idea, because again, we're dealing with true and false. And so, but what happens is if you multiply 1 times 1, which would be true and true, you get 1, which again corresponds to true. And so we're going to look at these in more detail. Or operates roughly like addition, and then not operates like negation, like a negative sign. If something is true and you negate that, or you say not that, then it's false. If you say not something that's false, then that is true. We're going to look at truth tables that will describe these kinds of operations. And so the truth table will organize the data in different ways so that we can see exactly what happens when these various operations are applied. So let's say we're given a Boolean statement A, so some statement that's true or false. If we look at this, then we have A can be either true or false, and so then not A is going to be the opposite of that. If A were true, then not A is false. If A were false, not A is true. If we have another statement, some statement B, now there are 4 situations that we can look at. Both A and B can be true, in which case A and B is true and A or B is true, because in this case, or means one or the other or both. Or in logic is an inclusive or, one or the other or both. A and B could be, A could be true and B could be false. And we see the second row then tells what happens. A and B, true and false, is false, but true or false is true. So one or the other, again, or both. The third row has A being false and B being true. And we see the results, and is false, but or is true in that case. And the fourth row, if both statements are false, then both of these operations yield a false conclusion, a false statement. And so the idea of these operators are being applied to statements that are either true or false. Again, the or operation is an inclusive or, and it's true when one or both statements are true, but in typical English, or is used as an exclusive or, one or the other, but not both. And so in that case, if we have the but not both scenario, then we sometimes use a new operator. The operator is XOR. And so XOR can be created from using and, or, and not, but what it means is one or the other, but not both. And so a way to get XOR is to say, well, we could have A or B, but we don't want both A and B. And so XOR, building it from and, or, and not, requires us to look at A or B and then to rule out the possibility of having both A and B. And so the order of operations can be specified here with the brackets. There are orders of operation that mimic the multiplication and addition and the negation that match the idea of the numerical order of operations. But here we're specifying with the brackets of do this, then do that, then do this other thing, and so on. Again, matching the mathematical typical numerical order of operations, we do what's in brackets first, then we do any negation, then and, then or. So it's parentheses and negation and multiplication followed by addition, roughly. So we can create other more complicated expressions from this starting point of and, or, and not. So Boolean expressions in Python, the and, or, and not that we wrote in capital letters in logic just to make them easy to see, in Python are written in lowercase. So true and false are actual values that are capitalized. First letter is capitalized. And if you type these in, say, idle or PyCharm, if you type the expression true or false, you will see the color code, the color changes as appropriate to represent that these have specific meanings in Python. So true or false, if you type that, print that value, you will get true as the result. If you print true and true, again, that is true. True and false, as we expect, is false. Not true, again, is false. We can do more involved, true or false and true. Now, the order of operations on this is that and takes precedence over the or. So what happens? False and true is false. True or false is true. So this is a true statement. However, with this particular expression, if we had grouped the first two together, we still get true. And if we group the second two together, we still get true. So in this particular case, the order of operations, it can be interpreted as having either of these meanings and still get the same truth value. Now, again, which is the correct interpretation? The correct interpretation is the final one that's listed here. But the end result is that the statement is a true statement. So when we're combining things and creating more complicated statements, we do have to be careful. What are we really wanting to put together? Which pieces are supposed to be done first? And or. And so if we need something to go out of order from the regular order of operations, we need to make sure that we use those brackets. So what if we had a statement like this, true or false and false? This time, if we put the parentheses in different places, we do get a different result. And so in this particular case, again, remembering that and comes first, we can determine what the correct value is. But if we need to have this interpreted in a different way, then we need to make sure that we use those brackets appropriately. So let's apply some of this to a common kind of programming exercise that is sometimes shows up in programming interviews and in other scenarios. a program called FizzBuzz. And the idea of FizzBuzz is to print all the numbers from 1 to 100, except anytime you see a multiple of 3, you replace that with the word fizz, and any multiple of 5 you replace with the word buzz, and then anything that's a multiple of 3 and 5 gets replaced with the combination fizz, buzz, a single word in that case. And so we're going to go through each number and replace the number. Well, if the number is not a multiple of 3 or 5, we just print that value. And if it is a multiple of 3 or 5, we replace it with the appropriate value in this case. We're going to do a slight variation on the theme. We're going to print the number and then the appropriate output beside that number. So rather than just creating a list of numbers from 1 through 100 with values being replaced, we're going to print the numbers and then beside the number have its appropriate output. So something like this, we would print 1, and beside it have the 1 because that's the correct output. 2 has the correct output. 3 gets replaced with fizz. 4 is 4. 5 gets replaced with buzz. And so on until we get to, say, 15, and then 15 is FizzBuzz. Okay, so we're going to see how to create this using this kind of looping structures that we've been discussing. So in order to do this, we have to be able to check to see whether the condition has been met. Is this number divisible by 3? Is this number divisible by 5? And so when those conditions are met, then we're going to do something different. So these conditions, is this number divisible by 3, corresponds to a Boolean statement. And so we're going to apply that to that true or false portion to have, if this statement is true, then we're going to do this thing, and if it's not true, we'll do something else. Okay, but we do need the looping as well. So we want to start with 1 and go up to 100. So we can have this loop with for I in range 1 to 101. Again, starting at 1, going up to, but not including, the number 101. Now we're going to, in this case, create kind of a variable that just holds an empty string that says we don't have a value for this yet. The value is either going to take on the numerical value or be fizz or be buzz or be FizzBuzz if necessary. And so this first check that we do is when we run into the number, we want to check to see whether or not it is divisible by 3. And in Python, the percent is the modulus operator. And what the modulus operator corresponds to, at least with positive numbers, is positive integers, is the remainder when I is divided by 3 in this case. So we say, let's take the number, divide it by 3, look at the remainder. If the remainder is 0, then that means that I was divisible by 3. And in which case, we're going to change the value of the string value that we've created. We're going to modify it by adding fizz to that. Now, again, value is an empty string, and if we add fizz to that, then that will update its value to be fizz. We could just have set it equal, but I wanted to point out that plus equal is Python shorthand for saying update value with value plus fizz. And so we're going to probably use that quite often. It doesn't carry over to lots of other languages, and so it may be a good habit to not use the plus equal. But it corresponds to saying update the thing on the left-hand side by adding the thing on the right-hand side. And in this case, addition with strings, remember, is concatenation. So it's just going to put things together. All right, so if we run into a number that is divisible by 3, then we're going to output, or not output anything yet, we're going to update the value to be fizz. If we run into something that's divisible by 5, then we're going to do the same thing, except now we're going to update the value with buzz. Now, what would have happened if the number is not divisible by 3? Then that first portion gets skipped, because that if I is divisible by 3, the tabbed portion only carries out if that part is true. It's false, so it would skip over that. But what if we had a number like 15? With a number like 15, it would check first to see if I is divisible by 3, which 15 is, and so it updates value to be fizz. And then it goes on to check to see, is 15 divisible by 5, and it is. So it updates that with buzz. And so for I equals 15, we have value being FizzBuzz as we want it to be. On the other hand, if the number is not divisible by 3 and it's not divisible by 5, then value hasn't been updated and it's still an empty string. And so in this case, we're checking if value is still an empty string, and the two equal signs are how we check for equality. We say, is the value the same as the empty string? And in that case, if it is, we're just going to put in whatever the I value was. Whatever the number was, put that in place. And then we will print I, which is the number, and then we will print value. And so in the case when I is 1, we didn't update anything with fizz or buzz, and so value becomes 1, and we're going to print 1, and then the comma value in the print statement. What it outputs is it gives us a 1 with a space and then the 1 beside it. We get to 2, same thing, we get 2 space 2, but when we get to 3, 3 does update value to fizz, and so we get 3 space fizz. We get to 5, we would have 5 space buzz, and so on until we get to 15, and then we would get 15 space FizzBuzz, and all the values from 1 up to and including 100 would have the appropriate value. Each one of those will be on a separate line the way this is printing. So you would have on the left-hand side numbers 1 to 100, and on the right-hand side the appropriate output, determining whether or not the number is divisible by 3 or it's divisible by 5. Now this is a pretty straightforward approach to the FizzBuzz problem. There are some really nice mathematical calculations that can be done to eliminate the if statements, doing these other calculations, and using some extra Python kind of tools that will create the same desired results and work in other scenarios. This program only works if I is 3 or 5. We could modify it to work in other scenarios if you did change the divisible by 3 to something else and divisible by 5 to something else. And so the idea, though, is we have looping going from 1 to 100, and then we have these conditional statements that are testing to see whether certain conditions have been satisfied. Those conditional statements in FizzBuzz are independent of each other. If something is divisible by 3, it doesn't tell you anything at all about whether or not it's divisible by 5. And so we had separate if statements in those cases. But in some situations, we might have a sequence of related conditions that need to go in a particular order. And so if we had condition 1, so if condition 1, then do something. Condition 2 might be not independent of condition 1. It might be that if you see condition 1, you immediately do this thing. But if you don't see condition 1, then you're going to maybe check to see if condition 2 is satisfied. And so we have in Python an else if construction. And so this is elif is the way it's shortened. So if the first condition is satisfied, you just do that and then you're done. But if the first condition is not satisfied, you look at the second condition to see whether or not you should do something in that case. And you can have lots of elifs, you can have multiples. And then often what we have is at the very end an else. that if none of those previous conditions are satisfied, then just do this last thing, whatever it happens to be. But it's not necessarily the case that we need an else statement. You can have an if, like we've already seen. An if can stand alone. You can have an if and an elif, and then not have the else. But often we will have the else to kind of cover for other scenarios. So again, we'll see that as we go forward to see whether or not we need the else in different situations. But what happens in this construction is only one of these conditions can be satisfied. Notice again on the else, we don't specify the condition. Else just means anything else happens, do this last thing. But as soon as one of those conditions is satisfied, Python will do what is in the tabbed portion in the statement itself, and then skip all the way to the very end after that and go on with whatever comes below. So in an if, like we just saw on FizzBuzz, you had an if followed by another if. Python will check both of those. But if you have an if with some elifs and maybe an else, Python only checks until it runs into a condition that has been satisfied, something that is true. Of course, if it gets all the way to the else, then it's tested everything. But usually then what we would do is if we had multiple scenarios that were of interest to us, that we would put the most likely one to be satisfied, put it close to the top, put it first or second. Put them kind of in order of most likely to be satisfied. And that way that will save Python from having to do so much checking as we go through the program. Instead of having to check every single condition, it only checks until it meets the true one, and then it can skip out and go on with the rest of the program. And that will make a huge effect in some of the algorithms that we'll see later. Just the order you do things can have a huge effect on how long a program takes to run. All right, so this gets us to the point of indefinite loops. These are loops that we don't know whether they will be carried out, or if so, how many times. So we can't do the counted loop procedure, but we can use this idea of these conditional statements to be able to do the work that we want and do it the right number of times. So again, let's say we specify the value as an empty string, and we want the user to enter a value when prompted. So while value is still an empty string, again, remember we're testing for equality here. While it's an empty string, we tell the user to give us a value. And in Python, the way that's done is with this input function. So you say value is going to take on the value of whatever the user puts in. So enter a value, we give them a prompt. If the user hits enter without typing anything, then value continues to be an empty string. And so what the loop will do is the loop will say, oh, value is still empty. Let's repeat this. Value is an empty string. Let's prompt the user again to enter a value. As soon as the user enters a value, now value is no longer an empty string, and we can break out of the loop and go on. So we have some thing that happens next, right? In this particular example, once the user actually puts in a value, again, it doesn't have to be a numerical value, it can be any keyboard character, but once they do that, then we break out and say, okay, this is what you entered, this is the value that we have. And so what happens in this case is we don't know how many times this loop might need to run. We know it will run at least once because value starts as an empty string, and so that condition is satisfied at the beginning. But if the user follows instructions, then it will only run once. But if the user doesn't follow the instructions, then the loop may have to execute many times until they finally enter something. And you can use this to check for things like making sure they're actually putting in a number. And so you check to make sure that it's a number, or make sure it's the right kind of number, or it's in the right range, and so on. So there are lots of other things you can do. All of our statements so far have mostly, the indented portion has been one line. You can have multiple lines in there to determine what happens when this condition has been satisfied. To apply this to a more general kind of problem is the Collatz problem. This problem is sometimes called the 3n plus 1 problem. You start with a number. If the number is even, you divide it by 2. If it's odd, you multiply by 3 and add 1. And you keep going until you get to 1, because what happens if you get to 1, then it's an odd number multiplied by 3 and add 1. That gets you to 4. Then you divide by 2. That gets you to 2. Divide that by 2, gets you back to 1. That goes then 4, 2, 1, 4, 2, 1, 4, 2, 1 at the conclusion. So what happens in the Collatz problem, as soon as you get to 1, you stop. This problem is a famous problem. You can look that up. Sometimes called the hailstorm sequence. Sometimes it's called the Syracuse problem. If you haven't heard of that before, it's a straightforward statement, but no one knows, for instance, whether every number that you put in ultimately gets to 1. Everything that's ever been tried gets there. Some really big numbers have been tried. They all eventually do get to 1. But let's take a look at how we would write this as a straightforward implementation of the ideas that we've been discussing. So we're going to ask the user to give us a positive integer. So we have the input function. Again, we're not forcing that they give us a positive integer at this point. We could put that into a similar kind of indefinite loop, the while loop, to make sure they give us the right kind of value. But we're going to assume that they can follow instructions and they give us a positive integer. Then we're going to print that value. Now, while n is not equal to 1, and so the not equal in Python shorthand is exclamation equal. So while n is not equal to 1 is when we want to carry out the procedure. If n is 1, then we just stop. We got 1, we got to 1, and we're at the end of the sequence. But otherwise, what do? We check, first of all, to see if n is even. So we use the modulus operator, check to see if n is even, and if so, we replace n with n divided by 2. Otherwise, since n is a positive integer, the only other option is that it be odd. In this case, we replace n with 3 times n plus 1. Then we're going to print the n, print that new value, and then do this all over again. If n was not 1, then we're going to replace appropriately with n divided by 2 or 3n plus 1, print n, and check again, and keep going, and keep going, and keep going. And so what happens in this case is we have kind of a combination of all of the pieces. We have an input, we have some print statements, we're doing an indefinite loop, and in the indefinite loop, we are considering different conditions. So the indefinite loop condition itself is while n is not 1, and then inside the loop, there are some other conditions that we check. And if those conditions are satisfied, we do one thing. If that condition's not satisfied, we do something else. And we keep going until we get to 1. Again, the way this is set up is it prints each value on a separate line. If we had a very big n, this could go a long time. And so we could modify this and organize the data in different ways and do different things with it. But the approach here is we break things down into smallest possible pieces and then build around that and think about what do we want to do. All right, so as usual, feel free to ask questions in the comments, by email, or on Discord.